So last conic section we're going to look at is a hyperbola. And just like all the other ones, I'm going to start out with the definition. So first of all, a hyperbola is a two-dimensional shape. That's why we say it's a collection of points in the flat plane. And for an ellipse, we said that it was a collection of points in the plane such that the sum of two distances came out the same. Every word in this definition is the same, except that one. Instead of the sum of two distances being equal, it's the difference of two distances being equal. When we did it on an ellipse, what were the two fixed points that we measured the distance to? It was from a point on the edge of the ellipse to the two, yeah?
The foci,
yeah, the two foci. It's the same thing today. Those two fixed points are going to be the foci. So you're going to measure you're going to take your point on the hyperbola, measure the distance from your point to the first focus, measure the distance from that point to the second focus, and subtract those two numbers. That will always come out to a constant. The constant that it comes out to, I don't know. It depends on the hyperbola. Okay, but it always comes out to a constant. Yep.
The Monday unit was focus and directrix, or was that last week?
Monday we talked about the parabolas, yeah.
And those had the focus and directrix.
Yes, they did. Yep. Okay, so let's look at a picture of a hyperbola and then kind of see how that definition works. Okay, so that's an example of a hyperbola. So point E is a point on the ellipse. C and B are the foci. Okay? Just like when we had a parabola wrapped around the focus. That's kind of how these branches of the hyperbola work. Okay, they're called branches. They wrap around each focus. As I drag point E, which I need to do it from the computer, but once I drag it, these two numbers are going to change. But the difference between them in this particular problem is always 5.66. That's how it'll always come out. Let me just drag it so you can see it. So take point E, drag it. If you take 3.94 and you minus 9.6 from it, you will get 5.66. Okay, and of course, absolute value. Okay, absolute value. If I put the point on the other branch, still same thing. If you take 13.48 and you minus 7.82, you will get 5.66. So any question on the definition? That's a hyperbola.
Yeah, I was going to ask about the switching the lines, but you did that.
Yep. So it's the distance to the two foci subtracted coming out to a constant. And that's the shape we get. All right, so a lot of the vocabulary is going to be the same as yesterday. A little bit is going to be different, but you'll kind of see some connections. We don't have a major and a minor axis anymore, but we have two other names we use. All right, so the line through the foci yesterday, okay, we called that the focal axis. When you're talking about a hyperbola, they call that the transverse axis. And if you look at the word transverse, it kind of looks like the word traverse. And traverse means to go across from one side to the other. Like if you traverse the bridge, okay, you're going from one side to the other. When you have two branches of a parabola, the transverse axis is the one that goes across the branches. It's like a bridge. It's like it connects them. Traverse, transverse. Okay. if you find the midpoint of the segment that connects the two foci, that is called the center. That's the same definition we had yesterday. The midpoint of the line segment connecting the foci, or you could also say the midpoint of the line segment connecting the vertices. I haven't defined what the vertices are yet, that's why I didn't use that word. But if I click on, let me go back for a second. If you could draw a line segment between B and C, find the midpoint, that's the center. Just like yesterday, we're going to start out with hyperbolas that are at the origin, and then we're going to shift them using H and K. Okay, but for now, they're going to be at the origin. Okay, so the transverse axis, that's the one that goes across the two parts of the parabola. The conjugate axis is the one that goes between them. So the formal definition of the conjugate axis, it is perpendicular to the transverse axis, and it goes through the center. Okay, so that's the center. That's the transverse axis. That's the conjugate axis. The conjugate axis never touches the hyperbola. It goes right between them. And I keep drawing my hyperbolas horizontal. There are two different types. Okay, we've got that type, and you've got that type. This is where the branches are opening left and right. This is where the branches are opening up and down. And yes, you can do hyperbolas on an angle too. We didn't really talk a lot about this when we do it, but when we talked about rational functions, 1 divided by x, that is a hyperbola. But if you look at the branches, they're on kind of a 45-degree angle. They're opening up and to the right and down and to the left. And of course the calculator kind of stops because it's getting too steep. Right, but that is not the kind of hyperbola we're going to be focusing on. Just these two. Now, yeah.
So if that last one that we're working on, it was separated because of an asymptote. So would you consider this to have an asymptote separating the two?
These graphs, do hyperbolas have asymptotes?
But the last one is considered a hyperbola.
Yeah, so it's kind of like you have an asymptote there. So just going to take a look at that. So if we take that and we rotate it to make it kind of like what we're doing, okay, opening up and down. Okay, it's almost like we would have asymptotes, but they would be on angles like that. And we are definitely going to talk about having asymptotes. So yes, very good that you noticed that. So we're used to the asymptotes being up and down and left and right in the kind of ones we did before. Our asymptotes now are going to be on angles. Yep. But you're definitely going to have asymptotes. And the asymptotes are what's really going to help us to make the sketch. Because if you have both your asymptotes, then all you have to do to make your sketch is draw the branches and stay inside the asymptotes. Yep. So we'll talk all about asymptotes. I've been using this word already with you. The two pieces of the hyperbola, those are called the branches. And the branches can open left and right or up and down for what we're doing. Right? So if these are what your branches look like, and you draw in your transverse axis, like that. The 2 points where the transverse axis intersects the hyperbola, those are called the vertices. So this would be like V1, V2. And remember where the foci are. Let me go back. The foci are what the branch wraps around. Okay. So the foci would be like over here and over here. How does the position of the foci in that picture relate to the position of the foci in the ellipse? I kind of want to compare where the foci and vertices are. Yeah?
They're flipped.
They're flipped. Yep. So in an ellipse, these are your vertices, and your foci are inside. Now the foci are outside. And you're going to see a lot of that idea today with ellipses and hyperbolas. Everything is kind of switched. And that's how you get a hyperbola. Okay, so equation of a hyperbola. Well, you're going to notice a lot of the stuff looks exactly the same when I wrote it for an ellipse. The center is at the origin. The foci are C units away from the center. The vertices are A units away from the center. That's the same. And this is going to be the one where the transverse axis is horizontal. So we're talking about one that looks like that. So look at the equation that's in the box. The equation, the left box, not the right box. What's the difference between this equation and the equation we had yesterday? Yep.
We're subtracting now.
Yeah, we're subtracting instead of adding. And if you look at the formula that connects A, B, and C, yesterday it was C squared equals A squared minus B squared. Today it's C squared equals A squared plus B squared. So what I want to do, same thing I did yesterday, I want to show you the case where the transverse axis is vertical. Look at the formula, and I want to see if you can just quickly tell me what's changing. Okay? Yesterday we saw what changed. Okay? The A and the B switched places. That's not what's going to happen today. So make sure everybody has that first. And then we'll look at the other formula. Yep.
So yeah, I remember that A and B are both greater than 0, and that B is greater than A. So is that still the case for the new formula?
Nope, that's not written here. Nope. So A is not necessarily bigger than B. A could be bigger than B, A could be smaller than B today.
But I'm pretty sure both of them can't be 0.
Yeah, we never want them to be 0 because then you'd be dividing by 0. So yes, they can't be 0.
But they can't be less than 0.
No, they'll still be positive values. The only negative you're going to have anywhere usually in this formula is right in the middle.
Yeah, but I'm sorry. What I meant is like yesterday, like both of them are greater than 0, and then they're greater than each other. So the difference here is that they're not greater than each other, but they're still greater than 0.
Yeah. Yep. It's still going to be greater than 0. All right, so let's put up the other one and look at the difference. What's the difference between this formula and the other formula? Yeah? Yeah, it's which one in the numerator comes first. So today, it's the 2 in the top that switch places. So how do you tell which way the transverse axis is going to go? Well, yesterday you could tell by looking at the bigger number. Okay? Today you're going to tell by looking at which letter in the top is positive. I would consider the negative here to go with the x because it's in front of it. The y is the positive. So the transverse axis goes in the y direction. Okay, we go back to this one. In this case, the x is the positive. The negative goes with the y. Since the x is the positive letter, the transverse axis goes in the x direction. Okay, so it's all about the letter that's positive today. Very different than how we did it yesterday. And now there's one other thing we're going to talk about here that somebody already brought up. The asymptotes. Okay, the asymptotes have a very specific equation. The asymptotes for this one go right through the origin, so you don't have to worry about a y-intercept. All you have to worry about is the slope. The slope is b over a. So when the transverse axis is horizontal, the slope is b over a. So I remember HBA. HBA. Horizontal, b over a. We're not quite there yet, but does anybody know what's going to happen when it's vertical? It's not going to be b over a. Yeah?
H A over B? A over HB?
No, when it's vertical. It's not horizontal, just when it's vertical.
So when it's vertical, it's going to be A over B.
It's going to end up being a over b. So VAB. Maybe that one's easier to remember. So if you remember VAB, VAB, vertical, the slope is a over b. Horizontal is b over a. Okay, so this part is new. We did not have asymptotes with ellipses. Yes?
Asymptotes always go through the origin when we're not doing transformations.
Well, they only go through the origin if the center is at 0, 0, which is just what we're starting. Eventually, they don't go through the center, and then we'll have to figure out. When the asymptote doesn't go through the center, it's really not that much harder. We just use point slope form to get the equation. Because the asymptote always goes through the center, and it always has the slope I just showed you. So you always are going to know the slope, and you're always going to know a point. So this is perfect for point slope. That's what we'll use in a little bit. But for now, you don't need point slope because it's at the origin. So kind of like a, actually, you know what, I'm not even going to worry about that. I would say when graphing the hyperbola, it's really helpful to find the asymptotes. That's the best thing. Okay, because the asymptotes are going to give you an X shape that's going to kind of pin in where you need to draw. So if your asymptotes look like this, and your branches were opening up and down, well, that's pretty much what your picture is going to look like. So what we'll usually do is find the vertices and find the asymptotes, and that's going to be all you need to make your sketch. All right, so this is pretty much the same as yesterday. A is the distance from the center to the vertex. C is the distance from the center to the focus. B, I don't think B has anything today that you can visualize. Like B was center to minor axis yesterday. There's no visual, I don't think, for B. It's just something we need when we write the formula. Also, it's a book, they put absolute value around the A because it is a distance. It always has to be positive. But it's never going to come out negative in any problem that we do, so I'm not sure we need the absolute value. I can't think of a case where it would come out negative.
I mean, what about just like saying the distance? Like, as in when you're not saying positions, you're just saying what the length of the lines are, the length of these things are. When you just want that, because you can't have negative, you can't have negative like distance. Like you can't have a negative 7-foot car.
Yeah, you can't have the negative distance.
So, but that's what I would think.
All right, so let's see if we can find the equation of this hyperbola, and they want us to graph it. All right, so the first thing that we know no matter what way the hyperbola is going to open, you're always going to have a squared as the first denominator. You're always going to have b squared as the second, and it's always equal to 1. Now it's just a matter of what letter we need to put first, x squared or y squared. Okay, anyone think they know which way the branches are going to open in this one? Horizontally or vertically? Yeah?
Is it horizontal?
It's going to be horizontally, because there's your center. Here's a focus over here, 3, 0. You also have one at negative 3, 0, even though they didn't say it. You've got a vertex at negative 2, 0, positive 2, 0. Everything lines up horizontally. So you're going to have something kind of like that. So when we want the branches to open horizontally, what letter do we want positive? Yep.
X.
X. There's your formula. Now we just have to figure out A and B. All right, well, I think we can get A. What's the distance from the center to the vertex? Yeah, 2. Okay, so we can get that. But there's no direct way to get B, so we have to get it using a formula. So, what's the formula that relates A, B, and C? Yep.
C squared equals A squared plus B squared.
A squared plus B squared. Okay, we know C, that's the center to the focus. What's the distance from the center to the focus?
3 squared 9.
Yep, so it's going to be 3 squared, which is 9. A squared, we already know that's 2 squared, which is 4. So what's B going to come out to?
Square root of 5.
Yep, square root of 5. Now, we don't really need B. What we really need in the formula is B squared. 5. And that's the equation of the hyperbola that meets those conditions. All right, and now they want us to sketch it. What did I say you should try to find when you're sketching? You've got to figure out something we didn't find here.
Asymptotes.
We need the asymptotes. Yep. When you're horizontal, what's the formula for the slope? Yep.
B over A.
B over A. So the slope is root 5 over 2, positive and negative. Okay, not a great number. So I'm going to change that to a decimal. So I have a rise that's a decimal and a run. Okay, so square root of 5 is about 2.2, roughly. So that's my rise, roughly, and 2 is my run. So we're going to go up 2.2 over 2 from the origin. And I already did. We're going to go up a little bit more than 2 over 2. Up a little bit more than 2 over 2. And because it's plus or minus, then you go the other way. You're going to go down a little more than 2 over 2. And then down a little more than 2 over 2. Okay, so we got our asymptotes. And the other thing I want to mark is my vertices, because we know that the hyperbola is going to go right through them. I've got one at negative 2, 0. Where's the other vertex? Yep.
The other vertex is going to be the direct opposite of it on the other side of the graph, which is going to be 2, 2, 0.
2, 0. And now we're going to draw our branches. And remember, as you draw them, they need to get closer to the dotted lines the further away from the origin you get. All right, so something kind of like That, and getting closer and closer. I like that. I messed up that second one a little bit, but. All right, there's your sketch. Any questions? Yeah.
Can you show how we found the asymptotes again after we filled in the formula?
How I graphed them?
How you calculate it?
How I calculate them. So the slope is b over a. So I used b, which was square root 5, over a, which was 2. Since square root 5 isn't a nice number for the rise, I just changed it to a decimal. So it's up 2.2, right 2.2. That's how I plotted a couple points for the first asymptotes. And then down 2.2, over 2. And I did that a couple times. And then you just draw your lines. Sometimes the slope will come out to a nicer number. Okay, with this one it didn't. All right, any other questions on that one? Okay, let's try this one. This one is the opposite. Now I'm going to give you the equation. I want you to tell me everything about it. All right. What is A in this case? Yeah?
4.
4. A is always the square root of the first denominator. That's for hyperbolas. What's B?
2.
2. It's always the square root of the second denominator. And then c squared equals a squared plus b squared. So c is the square root of 20, or 2 square roots of 5. Okay, someone asked me earlier about reducing that. I'll reduce it this time. Okay, so first thing we want to start with is the center. Where's the center?
0, 0.
Yep, you'll know when it's not 0, 0 because you're going to see a minus with the h, with the x, and a minus k with the y. Okay, but this doesn't happen. So center, transverse axis. Which way does the transverse axis go here? Yep.
It's horizontal.
It's horizontal because the x is the positive letter, so it always goes in the direction of the positive letter. Okay, vertices. How far away from the center are the vertices? Yep.
4.
4 units, and it's 4 units
Left and right.
left and right. So 4 units left of center, 4 units right of center. Okay, foci. How far away are the foci? Oh, I had everything already written. Okay. How far away are the foci?
2 square.
Yep, bless you. 2 square roots of 5. So you need to go 2 square roots of 5 units to the left and to the right. And what's the one other thing that we need that's new with hyperbolas? Yep, asymptotes. And what's my slope going to be?
1/2.
1/2. It's h is b over a, hba. 2 over 4. 2 over 4 reduces to 1 over 2. Okay. Any questions on finding all of those, especially the asymptotes, because that's a new one. Yes?
C is like, where, like, C are the foci data points, right?
C is the distance from the center to the focus.
Yeah, where the focus is. So they don't, would you say they technically impact like the asymptote? Because like even I mean asymptote, because like would if C was different, if C was like 4, would that change the asymptote?
Well, yeah, because it would impact how you're calculating A and B because they're all connected with that equation.
Okay.
So if you change one, it's going to impact the others. Yeah. Okay, same thing as last one, except what's wrong with this one?
The format.
Okay, can you tell me what's specific with the format?
First it's not equal to 1.
It's not equal to 1. You got to get it equal to 1. So let's divide everything by 36. Okay. Can someone tell me what that's going to give me for a new equation once I do that?
Like all reduced? Or?
Yeah, whole thing completely reduced.
Oh, okay.
X is going to be x squared over 4. You're going to have, it's minus 4y over 2.
Is it 9?
Wait, I'm
Is that y squared over 9?
Y squared over 9. Yep,
yeah.
and there you go. Now we're going to do the same thing here that we just did right here. But is the x, oh, the x is still positive, so actually it's the same type. So what's A in this case?
2.
2. B?
3.
3. And C squared equals A squared plus B squared. What's
Square root of 14.
13.
13? Yep. Okay, so go through it quick. Center is going to be 0, 0. Okay, the transverse axis is going to go which way? Because the x is positive. Okay, vertices are going to be what and what?
Positive square root of 13, and since it's like horizontal, it's going to be square root of 13, 0, negative square root of 13, 0. Oh, no, that's for the foci.
That's what, okay, we can write the foci.
2.
So the foci, he said positive and negative root 13, 0.
Yeah.
I'm going to do it that way. You can do it that way when the center is the origin, because the numbers are symmetrical.
Yeah.
So what are my vertices?
Positive 2 or plus minus 2, 0.
0. And my asymptotes, positive or negative,
3 halves.
B over A, 3 halves. Yep. Okay, so any questions on how we got any of those? All right, so I think we looked at the case where X is positive enough. Let's look at the case where Y is positive. So this is the equation where the center is still the origin, but everything now is above and below. Vertices are A units above and below the center. Foci, C units above and below. These are what switched places, the x squared and the y squared. Because the y is positive, that makes the transverse axis go in the y direction, up and down. All right, so we'll try a couple of those, and then we'll finish up with the ones where it is shifted. Okay, as long as you remember how to do point slope, then that's the only thing that is a little more time consuming when it's shifted. But point slope pretty much solves how to do it for us. I think I told you that, but I didn't write it yet. When you have a parabola that the transverse axis is vertical, the slope is A over B. Vertical is A over B. That. B. questions on any of those pieces of information before we look at some examples? All right, so you tell me, by now you should be able to tell me, what's the first thing I got? Yeah,
Divide everything by 4.
divide everything by 4. Okay, so I've divided everything by 4. What's the next 3 things that we usually figure out? Yep. We gotta, find, in this case it's 3 things, in the next problem it might be 5 things, A, B, C, H, K. Okay. What's A?
2.
2, B?
1.
Yep. And C?
Root of 5.
Square root of 5. Okay, that's all you need to describe everything. All right, what's the first thing you should write down?
Center.
Yeah, you can't figure out the center, you're not going to be able to figure out what anything is. You got to know where you're starting from.
0, 0.
0, 0. Okay, next thing.
Vertices.
We need something before we do that. Yeah, we got to know which way to go, up, down, or left, right. So we need our major transverse axis. Okay, transverse axis goes which way?
Vertical.
Yeah, because the y is the positive. Okay, now we could do vertices. What are going to be my 2 vertices? Yep.
0, -2, and then 0, 2.
Yep. 2 units above and below the center. Okay. What are going to be my foci?
0 plus minus square root 5.
Yep. Square root of 5 units above and below the center. And the asymptotes.
Is it 2? Or 2 over 1?
Yeah, it's going to be vertical is a over b, which is 2 over 1. So really, it's just y equals positive or negative 2x. Yep. And that's everything. Okay, any question on that one? All right, let me see if I got another one where I give you information, because we haven't done one like that. Okay, so let's try this one, and then let's try this one. Okay, so vertex is 0, 2, foci 0, -3, 0, 3, and the center is 0, 0. Okay. What's the first denominator when you're writing a hyperbola? It's always y squared. Second denominator?
B squared.
B squared. What always goes between them?
Minus.
And what always goes on the other side?
1.
Okay, so we can start with all of them. Okay, which way does the transverse axis go this time?
Vertical.
Yep, because your vertex is 0, 2, your foci is 0, 3, and -3. It's also another vertex at -2. So it has to go basically like that. Okay, so vertical. What letter does that mean I want first?
Y.
And second?
X squared.
Perfect. All right. Okay, so what, let's see. We gotta make our table for A, B, and C. Okay, what's A in this case? 2, center to vertex. What's B?
3. Is it 3?
Well, do we know B?
No.
No, we
can't.
don't know B. We have to derive that from other information. What's C?
C is 3.
C is 3.
Fast.
So C squared equals A squared plus B squared.
Square root of 13. Oh wait, no. 5.
Square root of 5. Okay. So our equation is going to be y squared over 4 minus x squared over 5 equals 1. That's the equation of the hyperbola. Any question on the equation?
Do you need to find asymptotes on this one?
Did it ask to find asymptotes? No, it technically didn't, so we don't need to. If you were finding them, let's see, it's vertical, so this would be A over B. So,
vertical or horizontal?
just by graphing your vertices, center, and foci, and see how they all line up. Yeah.
In the asymptote, if there's a square root on the bottom, do we need to change that?
So like if you ended up with like, say, y equals positive or negative 3 over square root 5x, like something like that. I would say I would probably leave it like that when you're finding the like the rise and the run, because it's going to tell you 3 up and 2.2 units right. If you rewrite it, it might be harder to see that, because then, yeah, if you rewrite it 3 root 5 over 5, now you're saying your run is a nice number, 5 right, but now you're going up 2.2 times 3, 6.6. So in terms of making it easier, getting the square root out of the bottom doesn't make anything easier. So I wouldn't worry about it for graphing. Okay? I would only worry about it if they specifically say, like, find the asymptote and write the slope without a square root in the bottom. That's the only time I would worry about it. Okay, I'm not going to worry about discussing this because we've done quite a few. All right, so again, as long as you understand the concept behind conics, you don't have to memorize, okay, if it's horizontal, it's h plus c comma k, like that all confuses me. There's just a lot going on. Okay. All we have to understand is this. Okay, our two equations. Up until now, the h and the k have always been what two numbers?
Oh, 0.
They've always been zeros. So if I cross these out and pretend like they're zeros, you get back the formulas I gave you. X squared over a squared, y squared over b squared. Okay. The difference now is the center is going to be at hk, just like an ellipse. H is always the number that goes in parentheses with the x. K is always the number that goes in parentheses with the y. So I can't say that the h is always first, because it could come in the second numerator. Depends where the x is. But h always goes with x, k always goes with y. And if you're looking at this and you're like, wait a minute, that's not what he told us, that's the same thing I told you. If you rewrite it, c squared equals a squared plus b squared. Okay, and as far as asymptotes, again, this is really point slope. I don't really think of that when I do it. I know point slope. Okay, so I just remember, all right, my point is the center, and my slope is either a over b or b over a. Okay, but that's all the asymptotes are. I don't try to memorize them because it's just, I know point slope. Okay, so that's all I need to know. If you don't really understand conics and what you're doing, then yeah, you might have to memorize every single thing in this table because you don't really know what you're doing and you're just like memorizing information and just trying to write it down. But if you understand it, you don't have to memorize any of that really. Right, and then they give us a couple pictures. Just an example where the branches are horizontal with the vertices and foci, and then an example where they're vertical. Okay. So let's try an example. So find the equation of the hyperbola where the center is 1, -2, focus is 4, -2, and the vertex is 3, -2. Okay, what are the first 5 things that you should write down? whether I give you this information or I ask you to give that to me. Yep.
HK, ABC.
Yep. We need the HKABC. Okay. What is H in this case? Yeah. 1. What's K? -2. Okay. What's A? Yeah.
B3. Oh, would it be 2?
2. It's the distance between the center and the vertex. 1 to 3. These two numbers are the same. They're both down 2. It's just one of them is down 1 in right 2. One of them's down 3 in right 2. So the distance is 2. Do we know B? No. Do we know C? Yeah. What's C? 3. So C squared equals A squared plus B squared. Okay. What's B gonna be? Square root of 5. Okay. So we got all that stuff. All right. So the equation, is this going to have the branches opening horizontal or vertical? Yeah.
Horizontal.
Yep.
So it's going to have x squared first
Yep.
over the.
Just so everybody knows why it's horizontal, your center is over 1 down 2, your focus is over 4 down 2, and your vertex is over 3 down 2. Everything's lining up horizontally. So you said which letter is going to be positive?
X squared.
Yep. X. And what letter always gets paired with the X when we shift?
Y.
What letter? A? No. Not. What letter gets paired like in parentheses with the X? Yep. H. So the X minus H go together. The denominator will be the A squared. And then we're going to have minus what letter gets paired with the Y. That's the K. Over B squared. And that equals 1. All right, let's write our equation. Okay, so it's going to be x minus 1 squared. What's my denominator going to be for the first one? 4. Okay, what's going to go in parentheses in the second numerator?
Y plus.
Y, it's going to end up being y minus minus 2. So it's going to be y plus 2. So plus 2. And my denominator? 5. And there you go. That's the equation of your hyperbola. Any question on that? Okay, or any question if I gave you something like this and had you work backwards to tell me the center, focus, and vertex. All right. Now, what if I gave you something like, let's just say we had a vertex at 0, 3. And then I told you one of the asymptotes. Let's say the asymptote is y equals, let's say, 3 over 5 x. And I asked you to tell me the equation. Okay, you have enough information there to figure it out. You need the A, the B, and the C. Okay, and I'll also tell you just to make this one simple. The center is 0, 0. What's A in this case?
3.
Yeah, A would be 3. Let me just check this slope and make sure I did it the way I wanted before we keep going. So center, 0, 0, vertex, 0, 3, vertical is going to be A over B. Yeah, that's good. All right. What's B? Yeah?
5.
5, because this is vertical, right? It's going to open up and down. Because it's vertical, the slope is A over B. There's your A over B right there. So B is 5. And now you could get C by doing C squared equals A squared plus B squared. So that's going to be the square root of 25 plus 9. Now you got everything you need. Okay, but that's a little bit different because we're not used to that with an ellipse. But I could tell you an asymptote and then another piece of information. And you can figure out the A and the B from that. So any question on that kind of problem? Okay, so it's really just putting all the kind of pieces together.
So, C squared equals A squared plus B squared for these ones, but for the ones we were doing Tuesday, C squared equals A squared minus B squared.
Yep, that's for an ellipse.
For an ellipse.
Yep.
And so we've gone over ellipse, hyperbola, and anything else?
Parabolas, and we did talk about circles as a special case of an ellipse.
But they all follow the C squared equals A squared minus B squared thing.
Well, no, not all of them. Today it's C squared equals A squared plus B squared. Yesterday it was minus.
No, I mean the circle, the parabola, and the ellipse all follow the minus 1. Those 3 don't follow the minus 1.
No, hyperbolas, it's C squared equals A squared plus B squared. The only one that does the minus is ellipse. Parabolas don't use that at all.
Oh,
Yeah. So yeah, a lot of little things to remember. Any other questions about hyperbolas, ellipses in general? Okay. So homework, I think I need to double check that one, so let me check that. Page 411, 13 to 16 is matching, that's okay. 17 to 21. So that's homework for tonight. So 13 to 16 all, and then the rest is odd. It's 17 to 21 odd, 29, 31, 37 to 41 odd. And that finishes up Conic sections.